it's taken over the universe. It's taken over the universe.
Well, this is asteroid Kilimanjaro. They found that via direct imaging, mass eight and a half tons times 10 by the 11, which is really big. So this asteroid looks like it takes about 6 years to make it around the sun. So this is on a 6-year orbit, and obviously it's 4.5 billion years old, approximately the age of the solar system. All right. Let's go to the sun. That's our sun. I mean, you might have heard this in school that our sun is an average star, but it's really not average. I think the percentage of sun-like stars in our galaxy is somewhere around like 12% or something, or 15%, something like that, between 10 and 20%, which doesn't sound like a lot, but out of 2 to 400 billion stars, that's a lot. But still, it's not average. It's not the by any means. For instance, our star is a G-type star, and it's actually abnormally quiet as stars go. Like as far as like the solar storms and coronal mass ejections and stuff like that. So it's really kind of quiet, and what's the word I'm looking for? Benevolent, maybe? Yeah. So basically, the sun, powers almost all life on our planet. Basically, all the life on planet Earth is powered by the sun and sunlight. Okay, so the sun basically powers all life on our planet. It powers our climate, which basically, allows life to not only live but flourish. Powers photosynthesis. That's how plants, take the energy from the sun and use that energy to convert it into like sugars and starches or something like that, and that's what they live off of. And also carbon dioxide. They take the sunlight and carbon dioxide, combine that to make basically food, and the waste product of photosynthesis is actually oxygen. And oxygen is what we need to live, amongst other things. So yeah, and the sun allows that to happen. So without the sun, none of us would be alive. There could still possibly be life on Earth, but it'd be powered from some other type of energy. You know, something like hydrothermal vents down in the bottom of the ocean. You know what I'm saying? Like these black smokers and all this stuff that's down on the bottom of the ocean. Because there is life down there that derives all of its energy from the chemical energy coming out of those vents. Doesn't depend on sunlight at all. So that's why, you know, there's a high chance that there is life on some of these other solar system bodies. But yeah. Quick little fun fact. Light, the speed of light is 186,000 miles per second, which basically is 671 million miles per hour, which is super fast. So that means the light that left the sun, the light that's hitting you now, or the light that hit you from the sun, left the sun 8.5 minutes ago, and it's just now getting to you. You know what I mean? That's crazy, right? Yeah. So it's 93 million miles was an astronomical unit, the average distance between the sun and the earth, and it takes light 8.5 minutes to traverse that distance. Quick little fun fact. All right, let's see. So we used to have actually 9 planets in the solar system, but then Pluto was demoted to a dwarf planet, so now we have 8. But coincidentally, we actually they think there is another 9th planet out there somewhere that they're searching for. But here's the first planet in our solar system, Mercury. All right. So that'll be the first one. Really hot there on the day side, really cold on the night side. Like the average temperature difference is like something like 300, 400 degrees. So like if you're on the day side, it's 400 degrees. But you stick your hand on the night side in the shadow, it'd be like negative, 400 degrees or something like that. Well, that's crazy. And the reason why that is because Mercury has no atmosphere. So the atmosphere here on the Earth kind of distributes the heat evenly. You know what I mean? So that's the first planet. You got Mercury, Venus, Earth. It was like my very something mother. So let's go to Venus. There it is. See, Venus is really, really close, really Earth-like as far as its mass and its distance away from the sun. And at one point, Venus was Earth-like. You know what I mean? It had water, it had all those things on it, but basically, a runaway greenhouse effect happened on Venus, where it just got really hot. All the water evaporated, turned into steam in the atmosphere, and there's also some evidence of some big volcanic event that released a lot of carbon dioxide into the atmosphere, and carbon dioxide is a greenhouse gas, which in turn also made it hotter. So then as all the water, rose up to steam in the atmosphere, because Venus doesn't have a strong magnetic field to protect the atmosphere from the solar wind, you know, that solar wind could come and like hit the water molecules in the atmosphere and split them apart and break the hydrogen off of the oxygen, because it's water is H2O, so it's hydrogen and two oxygen molecules. So when the sunlight comes and splits that molecule in half, it breaks the hydrogen away from the oxygen, and hydrogen is the lightest element. So that would just go ahead and float off into space. And then that's why Venus has no water today. I mean, I think the Soviet Union sent some probes, the Venera probes, to Venus. But I mean, it's like too hot there. It's like 800 or 900 degrees Fahrenheit, and then there's so much atmosphere, like the pressure on the surface is like you're under like miles and miles of water, like it would crush you flat. But the Soviet Union, they did send some probes there, and a few of the probes that got to the surface, were able to survive like I want to say maybe like an hour or something like that before they were crushed and burnt. But yeah, I mean, that's a huge accomplishment to get anything down to the surface of Venus. But again, like I was saying, those black streaks they think might be some form of life in the atmosphere, because if you get up high enough up in the Venusian atmosphere, it becomes Earth-like. The pressure goes down, the heat goes down. So if you can, and then they have some missions that stuff's gonna be floating in the atmosphere, stuff like that in Venus. Yeah, but yeah, okay. So Mercury, Venus. Obviously, we went over Earth. My very excellent mother. So the M stands for Mars. Let's go check out Mars. Ah, there we go. And again, Mars was Earth-like at one point. Actually, they think Mars was, Earth-like before Earth was Earth-like, as in, Mars is smaller, so it cooled down faster. So the surface wasn't molten as long as the Earth's was. So that means it cooled down. There was a hard surface. There was water on the surface. But the problem with Mars is that, see, it's like 10% the mass of Earth, and that mass allows the planet to stay hot inside, allows that molten core to stay hot and keep churning and turning, and that's what creates a magnetic field. The same thing that we have here that protects us from the solar wind. Because Mars was so small, it basically went cold on the inside, and that stopped the planet from producing a magnetic field, which in turn then allowed the solar wind to pick the atmosphere off. So that's why Mars is cold and dead today, because first of all, it was too small to hang on to its magnetic field, and also because it's a lot smaller and a lot less massive, it's also not able to hold on to the atmosphere because it doesn't have enough gravity to do so. So not only does it not have the mass to hold on to the atmosphere, but it lost its magnetic field and allowed the solar wind to pick the atmosphere off. So that's why Mars is cold and dead today. But it obviously had water on it. I mean, they know that, and that's actually why it has a red surface, because that's rust. That red is rust, and what makes stuff rust? Water. But there's for sure still life on Mars. It might be single-celled life or some type of bacteria or something, but it's gonna be down in the crust of Mars, where there's still water, where there's still a little heat, radioactive heating and stuff like that. You know, there's life in Mars, and there's a lot of water on Mars too. It's just frozen, and there's also a lot of carbon dioxide that's frozen. Well, a lot of water and carbon dioxide at the poles, and carbon dioxide is just like dry ice, but there's water there too. And like they've been detecting methane, you know, seasonal methane that comes out for some reason, like during the summer and during certain times. And a big creator of methane here on our planet is life. It's a waste product of some life. So where's the methane coming from? Probably coming from some life that's, you know, way down in the planet somewhere or something like that. You know, possibly. I mean, there's also geological ways to make methane too, but because it's seasonal and it only comes out in certain parts and certain times, particularly when it's hotter out during summertime, I believe, you know, I'll say there's a, you know, 50% chance that methane is created by some form of life that's in the planet. All right. So what we got next in the solar system? My very educated mother, I guess just would be Jupiter. Jupiter. What about the asteroid belt though? The asteroid belt would be somewhere around here. Like Ceres, for instance. That's an asteroid. Let's go there. Wow. Yeah. Ceres, that's a big huge asteroid in the asteroid belt. Also, you see these little white patches right there? Oh, whoa, what happened? All right. Forget the asteroids. I'm gonna get lost if I do that. Jupiter. There we go. Jupiter, the largest planet in our solar system. It's basically like a mini solar system in itself. I mean, if Jupiter would have been able to accrete more matter, we would have had 2 suns in our solar system, and possibly we wouldn't exist. But yeah, Jupiter has you know, something like 60, 70 plus moons around it. It's like a little mini solar system in itself. Coincidentally, some of those moons have a high possibility of having life on them. For instance, let me say something. Jupiter, we're at Jupiter. I want to see these moons though. Yeah. So Io, but you know, there's probably no life on Io because it's just too close to Jupiter, and you know, it's in the magnetic field of Jupiter, which is like crazy. You know, too much radiation, and plus, you know, it's so close from that tidal heating that, you know, the surface of Io is resurfaced like you know, every day damn near, because volcanoes are always erupting on it because of all the tidal heating. So there's so much tidal heating, in fact, that any atmosphere or water that was on the surface has been boiled away and you know, gone off into space. But that gives you an idea of why there's probably a high probability of there being life on Europa. Because guess what? The same process is at work on Io and Europa, but the only difference is Europa is far enough away that the tidal heating isn't, outrageous, and it's able to hold on to its water and then its ice shell. So basically the outside is just an ice shell, but underneath that it's just like a planet wide. It's a moon, but a moon wide. I'm just gonna say planet wide ocean. Actually, this body has more water on it, 3 times as much water as all the oceans combined on our planet, but there's just an ice shell around it. But the same processes on Io that boiled off the atmosphere and the water and the ice and everything is at work on Europa, except for it's all up underneath the ice. So that tidal heating from Europa being in a elliptical orbit, which means sometimes it's farther away from Jupiter, sometimes it's closer. So it's in that orbit, the tidal heating is heating up the core of the planet, and there's volcanoes underneath there. You know what I mean, like deep sea volcanoes and stuff that's keeping that ocean hot, just underneath the ice shell. And also the ice shell, protecting whatever life that is in the ocean from all the cosmic rays and radiation and solar wind and all that stuff. And this moon's actually been here for 4.5 billion years. So whatever life started brewing in those oceans around the same time that it started brewing in our oceans has been in there evolving for 4.5 billion years inside that enclosed environment. So I'm telling you, bro, there's no telling what's under there, bro. That's crazy, right? See those streaks and stuff? Like, if we can get a closer look. Here, let me see if I can go closer. Those streaks are actually like pink. You know what I'm saying? Yeah. And they think there could be life. That could be life as well, bro. Like coming up, you know what I'm saying? Probably coming up to the top of the freaking the glacier, the ice shell, maybe trying to photosynthesize from the sun or something. You know what I mean? But guaranteed there's life in that moon. I mean, it has water, it has the energy source, it has carbon compounds, everything that life needs is there in the water, liquid water. So there's no telling what's in there. Also, Ganymede, another moon. And by the way, see the four biggest moons of Jupiter are called the Galilean moons, and that's because Galileo supposedly discovered them. Galileo. So those are called the Galilean moons. And basically, Galileo is, ushered in the scientific revolution. He was able, by observing Jupiter, he was able to see that Jupiter had these moons revolving around it. And what that did was debunk the myth that the Earth was the center of the universe, because he could clearly see in his telescope that Jupiter had moons orbiting it as well. So, that kind of debunked the whole thing about the Earth being at the center of the universe. But, he couldn't even really bring that out until he was on his deathbed. Because, the Catholic Church and all that, you know what I mean? They were against that type of thinking. So much so that Bruno was actually burned at the stake. Back in the Catholic Church burned him at the stake because he was saying that no, the Earth wasn't the center of the universe. There's more planets out there. There's life out in the universe. The universe is vast. Blah blah blah. They burned that man at the stake. You know what I mean? But yeah, Galileo. He's the one that, you know, kind of debunked that whole thing. So yeah, Ganymede actually. There's a really high probability that there's life on Ganymede, because Ganymede is actually the most massive moon in the solar system. All right, it has like 5 or 6 oceans stacked on top of each other, all with water and different forms of pressure. And listen to this. Ganymede is also the only other moon in the solar system that has its own magnetic field and magnetosphere. So what that means is the core of Ganymede is hot. It's molten like the Earth, so much so that it's generating its own magnetic field. So that moon's protected from solar rays, solar wind, all the, you know, stuff that the universe is throwing at you that wants to kill you. Ganymede has its own protection, just like the Earth does. And it has water. It has a couple oceans under there. And it's been there for 4.5 billion years. So, around the same time life got a start on Earth, you know, these moons were here too. And they had water at the same time. So there's no reason why life didn't start on them as well. And this one also had its own magnetic field. So high probability that there's life there. High probability. You know, obviously it's not going to be intelligent life, but you know, it's life. Doesn't matter if it's what kind of life it is. But if they can prove that life had a second origin, a second genesis right here in our own solar system, that means that life is everywhere in the universe. And it's only a matter of time before we find it. We're looking. And that's the last Galilean moon, Callisto. I mean, there could be life here too, but you know, I don't know. It doesn't have a magnetic field. I don't know if it has an ocean under there. I mean, water's everywhere in the solar system and the universe. So I mean, yeah, water, but you also need a energy source. You also need carbon compounds for life as we know it. So who knows? Next, someone argued the most beautiful planet besides the Earth and our solar system, the ringed planet. Saturn, the second most massive planet in our solar system. Look at that beautiful ring system. And those rings, the orbit of those rings, I think is like 250,000 miles. You know what I mean? I don't know if that's from here to here or from here to here. But yeah, the diameter of the rings is like 250,000 miles. That's the distance from the Earth to the moon. And even though they're so big, like the diameter of them is so wide, they're only like, look at this, they're only like a few tens of meters thick in some places. So maybe like, you know, a few tens of meters. All right, 10 meters is 30 feet. So maybe like 50 feet, 60 feet. in some places, that's real thin. That's why if you look at Saturn edge on, you know, you wouldn't even be able to see the rings. You have to be looking at it like this, you know, from this perspective or from this perspective to see those rings. But yeah, that's like a little mini solar system right there as well. Saturn has, like, I think the most moons so far out of any planet in our solar system. I think that thing has like 82 moons that we've discovered. There could be way more. But even Saturn has a few, obviously Titan. Let's check out Titan. Let me see. Let me see how we do that. Let's see if that takes us to Titan. Oh, Mimas. Alright, we'll do this. Let's go to Titan. Yeah. So, here's another very interesting and high probability place for life in the solar system. This is a moon, Titan, which is a moon of Saturn. The only moon that has a thick atmosphere around it. Thick atmosphere of nitrogen and carbon compounds like methane and ethane, but mostly nitrogen, which that's what our atmosphere is mostly made of, nitrogen. But this moon actually has liquid on the surface. It has huge lakes, but the liquid in the lakes isn't water. It's methane and ethane and carbon compounds, because it's so cold there that, you know, those compounds are gases on our planet because it's warm here, but there they can actually be in a liquid form on the surface. And, you know, liquid, an energy source, carbon compounds, high possibility for life on that planet. Very high. Although it would be life not like we know it. You know what I mean? It'd be some other form of life. You know what I'm saying? And we actually sent a probe down to the surface on the Cassini-Huygens mission. So we have pictures of the surface. You know what I mean? So we're going to be going back there. You can actually see the atmosphere. See that? Blue? Just like the Earth. That blue comes from like nitrogen. Yep. High possibility for life. Another interesting place that might have life around Saturn is a little moon called Enceladus. Right here. But we can't see it. Let me see something. I want to see this thing. How come we can't see it? I want to go. You know why? Because it's in the shadow. Alright, so right now, Enceladus, this is actually the brightest object in the solar system. But because it's in the shadow of Saturn, let me see something. Because it's in the shadow of Saturn, we can't really see it right now. Is it in the shadow of Saturn? Oh, I think I just need to get a better angle. It's in the shadow of something, god damn it. Why can't I see that right? I don't know. Might be one of my settings or something. But moving out from Saturn, my very educated mother just sent. So I don't know. I forgot how it goes. But moving on from Saturn, we have Uranus. Gas giant planet, kind of like Saturn and Jupiter. Has a little ring system, has a couple moons. There's a possibility for life on one of the moons there as well. All right. Pretty planet. Kind of featureless. Just got to know where to look. I think, was it Uranus that has the big storm on it like Jupiter? Yeah. Moving out. Neptune. Yeah. Yo, Neptune has the big storm. There it is right there. Bro, I think it's Neptune that has like, I don't know if it's 2,000 mile an hour winds or something like that. It's crazy. It's cold ice giant, but, you know, has a lot of heat coming from within the planet. Because the core is still molten. The core is still hot. Still cooling down. Still generating its own heat. Wow. But yeah, those are the planets of the solar system. There's the pole. Try to flip this thing upright. Well, you know what? I think Neptune, was it Neptune or Uranus that's on its side because it got hit by like a planet or something. One of those. And then here's Pluto. Pluto used to be a planet. It got demoted to a dwarf planet. Dwarf planet. Why does it look like that? Let me get closer. Yeah. And they thought Pluto was going to be like, you know, just like this dead, boring freaking ball of ice. But it turned out to freaking, you know, be geologically active, have a lot of stuff going on the surface. It actually has a, let me get this out the way. It actually has an atmosphere. But I forgot how long. Okay, I'll show you right here. Let me see. Axial tilt, gravity, orbital period. So every 248 years, it makes one orbit around the sun. Every 250 years. But it's in a very elliptical orbit, which means, you know, sometimes in its orbit, it's really close to the sun. At other times, it's really far. And also, its axial tilt swings by a bunch of degrees. So basically, when Pluto is at its point in its orbit where it's closest to the sun, and also when its axial tilt is right, which is like every 100,000 years or something, it actually heats up and becomes alive. All the frozen, you know, ices and atmosphere that's frozen and fell down on the surface actually heats up, it sublimates and creates an atmosphere around it. And then once you have enough pressure and atmosphere, you can get liquids to start to run on the surface, including water and all that stuff. And they think, you know, like every 100,000 years or something, Pluto kind of comes alive. And, you know, there's water there. There's water under the surface there. Could be life there. You never know, man. Life is life is, you know what I mean? It's like an infection. It's like an infection in the universe, bro. Just keeps spreading and spreading and spreading. Just like the coronavirus was. Kept spreading and spreading and spreading. They couldn't, you know, get away from it. Life is the same thing, bro. It's spreading and spreading. How do you think it got to the earth? You know, the earth isn't special. You know, the earth isn't the only place where there's life. You know, life probably came here. Either life is easy to make if you have the right conditions, or either life was spread here through panspermia. You know what I mean? We'll find out soon. Well, yeah, those are the planets of the solar system. Kind of just wanted to, do a brief tour of the solar system, kicking off this channel. You know what I mean? We'll go way more in depth in the future. Yeah. I mean, we can't forget. All right, one more stop. Let's go check out our moon, bro. There's the moon. You know what I mean? The Maria. That's like Latin for like ocean or something like that. So there's like seas of lava and magma, that came up to the surface, and that's what those black patches are. It's like ancient lava oceans. Yeah. Quick fun fact: July 20th, 1969 was when Neil Armstrong became the first, supposedly, the first human to step foot on another planet or another body, celestial body. Again, that was July 20th, 1969. It was Neil Armstrong. And they left on a Saturn V rocket on July 16th. So it took them about 3 days to get there. That was pretty crazy. I mean, I wasn't born. I wasn't born yet back then. But I can imagine for the people that were alive and that witnessed that had to be something crazy, right? Or are you one of those people that believe the moon landings never happened? That's another discussion. That's another video. But yeah. Fun fact. Also, there might not even be life on this planet, or life as we know it, or us, if it wasn't for the moon. Because what the moon does is it stabilizes our orbit, so that way our axial tilt doesn't swing wildly. Like the North Pole, it kind of stays in the same. It varies by a few degrees, but it stays within a small range, and that's what makes our environment, our climate, so reliable. So it's what allowed life to evolve for these 4 billion years that life's been on this planet. If it wasn't for the moon, the planet, the axial tilt would swing wildly, and what that do is make ice ages come and go like seasons, like weather. And that's not a good climate and environment for life to evolve in. Life needs stability, long periods of stability and habitability to evolve into something as complex and smart as us. So without the moon, we wouldn't be here. If that big asteroid wouldn't have hit 65 million years ago, we wouldn't be here. The dinosaurs would probably still be ruling the planet. You know what I mean? A lot of things, a lot of stuff out there, you just got to be aware of, you know what I mean? And just, it's like the butterfly effect. Little things that you do and little choices that you make now and that you've made in the past have the potential to affect you in big ways in the near future and in the long-term future. So, you know what I mean? Just, if you took anything from this video, take that away. Always make your next move your best move. You know what I mean? That way you set yourself up to be a winner. And you're not stuck trying to play things by ear and always coming from behind and, You know what I mean? Settling for less and making rash and fast and desperate decisions. You know what I mean? Just think a couple moves ahead. You know what I mean? Like a game of chess. Make your next move your best move. And by the way, chess is a really good game to learn. You know what I mean? Well, anyways, I'm gonna let you guys go with that. Till next time, Dark Matter Studios. Holla.